Hi guys and welcome. As I've said on the Voltara release video, next video about Voltara will be a build video where I will take you through soldering, setting up and getting the build ready to fly with Voltara and Kiss Ultra. It took a while with some unforeseen delays to get the first bigger batch of Voltaras. One reason being that I wanted to switch to 4mm holes to use gummies, and the second was production of the PCB and some holidays in China. I want to take the time at the beginning of the video and tell you a few things about the ESC which I might have missed or not emphasized enough in the release video. Voltara ESC runs its own firmware. It's designed to work hand in hand with the hardware, and that will generate a more stable and problem-free setup because everything is paired to each other and they work as expected. Compare that with an open source code that needs to adapt to a lot of different hardwares, and even then there might be issues. Voltara ESC has constant current monitoring. All this is done on a hardware level, and if there are currents exceeding the set limit, it will protect itself. For instance, if you have bad windings in a motor or any other electrical issues with a motor. Also, if you are pushing too much current out, because it's possible to use an extreme setup, and even then the Voltara will protect itself. It will handle a few spikes of currents, but if the high current persists, then it just disables and you will need to power cycle it to reset this function. A normal setup would not see this current tripping, except when you really have a bad motor, but at least you will find faster that your motor is dying. Okay, so as I've said, the big difference between the test production and all the prototypes is that the holes, the mounting holes, are not M3 anymore, and now they are 4mm for using gummies when you want to install the ESC. Using a gummy is pretty important, and I found out this on the testing phase. Despite the electronics being perfect, a very hard crash where the frame bends and automatically bending the PCB of the ESC. Capacitors are ceramics, so ceramics, as we know, crack pretty easily. So when you crack a capacitor, they short out, and because you have a pretty powerful current source like the battery, you will see a lot of flames, explosions and so on because of the capacitors. So to protect the ESC for pretty nasty crashes, I went with using the gummies. That way you guys will be worry free when you crash. Obviously, hitting the PCB itself in a crash, it's a no-brainer. You will damage something, so yeah. But I just wanted to say this so that you understand what's the difference between the test production and the final one, which is out now. Okay, this is my patient. A quad that I flew for the past 2 years, I think. It's one of my freestyle quads, which has analog setup on it. I do use digital, but I just don't like it for pure freestyle. It has its uses, digital, but anyhow, this is the frame I will put the ESC in. Obviously, you could use a low flow frame or any other frame you like. Just make sure that the base you are mounting the ESC to has a lower nut or a press fit nut. That would be ideal. You don't need to put anything else. In case of Impulse RC Apex, I just take out the lock nut because I don't see the reason for it here, because these screws are not structural in any way. So I just take out the lock nut and I use normal nuts. On some frames I even use plastic nuts here and I have no issues whatsoever. This way we can lower the stack starting point even lower. And because we have now gummies on the ESCs, this would help a lot. Okay, mounting orientation. How should you choose to mount your ESC? Well, depends on what you want. and if your build is generous with space or not. This is my usual setup on an Apex. I have the VTX and receiver one on top of each other. Because this is analog, the size or the height of this stack here is not much, so I have space here to put the capacitor, especially the one that comes in the Voltara package. But if you don't have space here, if you are flying a digital air unit here, you will not have space for this. Even if this is the designed position to mount the ESC in, with the front being where the connector is, that doesn't mean that you have to mount it like this. You can mount it the other way around with the LiPo pads facing forward, and you have here plenty enough space for a capacitor and routing the cables as well. I am not a fan of mounting the ESC sideways for two reasons. One being that the wires leading from the LiPo pads to the XT60 will see a lot of stress in crashes, and also because of the crashes you will have a big chance of hitting this connector and ripping it or messing the wires on the end of the connector. It works. A lot of test pilots use this setup, but I just prefer to use it either like this or like this. I protect the connector and I have space for capacitors, and I have very fast access to desolder a motor when I kill it. You will need to be prepared with a tip that is solid enough to be able to solder everything on the ESC, because it has a lot of copper, and anything you throw at it, it will suck up heat and you will struggle to solder anything on this. A tip like this would be ideal. As you can see, it's like a chisel type. Run away from tips like this. I hope you can see it. It's very pointy and thin, and this will not have the power to transfer heat to where you want to solder. So I hope you can see the difference between the two of them. What I normally do is take out the ESC from the frame, tin up every pad that I will use, solder the LiPo connection with the XT60 connector on it, then plug it in the frame and cut the motor wires and make everything fit. And let's start doing just that. So now you need to find a way to hold your ESC in a fixed position, and just take a vise like this one. It helps a lot. Okay, now we take the soldering iron, we clean the tip a bit, and we have the solder wire in our hands. And because the solder wire has flux already in it, we don't need to use any external flux. Almost any solder wire has flux already in it, so we are using that trick to make a clean soldering, right? I will hold the ESC like this just because it's easier for me to come in from this side. I put the solder wire onto the pad and I come with a soldering tip and hit it. As you can see, I already soldered it. My iron is right now at 350. I like it like that, but you can go lower if your tip is big enough. I'm not staying a bunch of time on the pad. I'm just worried right now that I just placed the enough quantity of solder onto the pad. So I touch it and I go with the wire in. And when I am happy about the quantity of solder on that pad, I will just finish. Right now I'm happy with the quantity of solder, and I go to the negative pad and I do the same thing. And right now I have a decent amount of solder already on the pad. And when I will be ready to solder the XT60 wires, in my case AVG 14, it will be easier. Next, I will do the same thing for the motor pads, and I just go, touch. When I'm happy with the amount, I go back. I'm not lingering there a lot, I'm just touching the pads. I turn the ESC so that my position is good. Okay, so touching the pad, going in with the wire, so when I deposit enough solder, I back out. From time to time, I tend to clean the tip. You cannot leave too much solder on the tip because it gets bad. So now it looks alright to me. And because I'm lucky and I know exactly the length of wire I need for the pigtail, the XT60 pigtail, I already prepared the pigtail and cut it at the right length. This is your job to know exactly how much wire you need. Sometimes when I build something new and I don't know the exact length, I tend to solder the wires and cut them when the build is almost finished and attach the XT60. But because this is a frame I'm usually building, I know the general length of the wire. And now I need to take out the amount of silicone I think I need on the ends of the wires. For this instance, maybe 2 millimeters, it will be enough. So I think this amount would do just perfect for this. Okay. Okay, I just secured the XT60 pigtail there. I take the soldering iron, I cleaned it, and the same process I did on the pads themselves, I will do to the ends of the wires. And make sure I thin everything. We need to make sure we leave enough time for the solder to penetrate all the strands of the wire so that we have a very good connection in the end. And I think this is enough. Obviously, you will need to take some time to let it cool down. We can switch to soldering them on the LiPo pads. I'm not going to solder now the capacitor. I will solder it in the frame to be able to see exactly how much I need to cut the lid. But the capacitor will be mounted right here on top of these cables. I will show you then how it is done. Right now I'm just going to put the wire down, coming in with a tip on top of the wire, letting it soak up the heat, and when I feel that the pad on the ESC melted, I just remove the tip. Same thing I will do on the negative pad. And that is done as well. If you feel that it didn't flowed correctly, like I see here on the positive one, you can just go back and hit it again. And now it's perfect. I can already see a little ball of solder here, and I will take it because we don't want solder balls on our electronics. The ESC itself has nano coating. It's some form of conformal coating, but a little bit thinner. If you know you are going to use this ESC in a very wet environment, or you know you are going to use it to film something on the water, then go right in and put some conformal coating now before you put it in the frame, because there will be impossible. I will just leave this one like it comes from the factory with the nano coating, which is more than enough for like a splash of water from, I don't know, catching me off guard when rain starts, and I will not be worried about that. Okay, now we are going to take it and prepare ourselves for the frame mounting. I have the frame here. I have the Kiss Ultra V2 here, together with my cam, and I will just leave them hanging behind. They will not interfere with anything I need to do now. So we have the gummies already installed. They are squishy, When you first look at them, they will feel maybe a bit too thick, but they are very flexible and squishy, so you can squeeze them a bit. Don't over tighten them so that you don't have any give when the frame bends. All right. So as I said, I like to install it as it was designed, with the LiPo pads facing backward. I'm just pushing it onto the screws. You will notice that my screws are not penetrating all the way through the gummies, and that's because the gummies are flexible, so when I push a bit, you can see the screws are poking out without any problems. We are going to install the rubber standoffs, and I think I need to say a few things about it. I use two types, because there are two types. The ones that you can find on Impulse RC frames, the same one is sold by Kiss Ultra store as well. And there are the Maytech ones. You can spot them pretty easily. The actual rubber section is the same on both. The top screw on the Maytech one is shorter and gives you a little bit more space on a very tight frame. The Maytech one is softer, so that might be an issue for some. Also, the Maytech one is gold-like inside, and the other one is silverish. I used the Maytech for a very long time, even maybe before Impulse actually started using them. So yeah, as you can see, this one is a lot more stiffer, and this one is softer. It's quite easy to see this. And because I don't have automatic focus on this camera, it's a little bit tricky. I hope you can see what I'm doing right now. So as I said, we don't see the screw poking out, but if we press a bit, it's right there. So we need to just come in with the rubber standoff, press a bit, and it will catch pretty fast. So the rubber standoffs are installed. I made sure to screw them not too much and equally, because now we have gummies that can be squished. You need to be sure that the screws are kind of equal so that the FC will sit parallel with the carbon. They will tend to squish out, which is normal, but if you take the side and you push a bit on the ESC, you will see that it moves. So that's a good thing, because we need that movement to be there to help us in relieving pressure on the PCB itself. My usual progression in building something like this would be right now to cut the wires going to the ESC. And how I do that? I just run the wires on the arm. I take them right up to the pad, and I take the wire cutters and I hold the wire with the wire cutters, and when I'm happy with the position and the length of the wire, I just cut it. And that's my first wire. If it's too long, I can just nip a tiny bit on the tip of the wire, and that's it. I do the same thing for all three wires. It's not a perfect science, so don't be stressed if you end up with wires longer or shorter. A very good trick is do the closest pad. Then after you cut the first one, you will take all three wires, and as you can see, the next pad is a bit longer. So if I take the third wire and I cut it same distance or just a bit more, if I run it on the arm itself, it reaches perfectly on that pad. Okay, I will not bore you showing you this for all the other motors. I will do it myself. Okay, so I've managed to trim every wire. Now we need to strip the ends just enough. My recommendation is to strip 1.5 millimeters. After a while you get used to how much wire you need to strip. I don't recommend to strip too much wire, because then you can make shorts and stuff like that. So 1.5 millimeters length is more than okay. Obviously this is my way of building, or I don't know, taking care of the wires. And right now we need to thin every tip of the wires. It's your decision how you want to thin it. Some people use helping hands, some people use some sort of gummy material to hold the wires and stuff. I just go doing this in the air where the wires are hanging. I'm thinning them and just go one by one. Obviously making sure you are not spilling anything on the PCB or any other electronic gear you have lying around. Now it's the time to solder every motor on the ESC itself. For this, I would recommend you to use a tweezer and take each wire into the position you want. I for one like to put wires on a slight angle facing the motor. This is my way of doing it. And the same technique I applied earlier. I touch the thinned wire on the pad, on the position I like. I go in with the tip and I make sure it's like centered, like that one. And I do the same thing for the rest. And this is one motor done. You just take the wires and you arrange them how you want. This is not an exact science, so sometimes you cut the wires perfectly, sometimes you don't cut them perfectly, but you just make sure you run them okay. In case of this apex, I have here a plastic cover on the wires to protect them from prop strikes. Yeah, this is the general rule of thing. You can also use your hand to position the wire, but as I've said, it's your own personal preference. Right now, what I like to do is just secure the wires. In my case, I will put the plastic protectors and use some electrical tape to secure them in place, and after that I will come back. And now the next section will be to install the capacitor. In my case, I run it through here, maybe a little bit angle like that. We take the capacitor, we make sure that we respect the polarity. We have the negative pin marked by this line here on the capacitor. That means that this pin here is the negative side of the capacitor, and we need to make sure of that. I just bend the leads down and do some visual measurements as well. Bend another time, and now I can go in and make another measurement. And now I can trim the leads, just making sure that the leads are touching the solder on the pads on a reasonably okay position. And now it's the tricky section, because you need a decent amount of heat, and you don't need to stay too much on the capacitor lid. You just need to touch, but don't stay too much so that you melt all the solder that's on the LiPo pads. You just need to melt the top section of the solder so that you connect the capacitor only. So we go in, we touch up the top, we do the same thing for the positive lid. So we touch up, and now it's the time where you can retouch from time to time just to be sure you connected it all right. You can turn the quad and touch from the other side as well, and that's a pretty okay solution. Now, the next thing you need to do is, if you are building a new, you take the cable that's in the Ultra package or Voltara package, is the same cable with the red wire here. It's a pin-to-pin connection. Ultra and Voltara are pin-to-pin compatible. If you are installing the ESC with some other fly controller, you need to go onto the website and check the information on how you need to repin your connector. But in my case, because I'm already installing this ESC into a quad that had an Ultra V2 on it, I already have the connector. It's in a good state. I like to twist the wires a bit just to protect them from excessive noise in the system. And now we need to plug the connector into the ESC. Be careful to line it up perfectly on both axes and then push it in. If you are trying to push it in at an angle, you will bend the inside prongs of the ESC connector side, and then you will have a lot of problems, especially if you bend the LiPo connection prong, which will result in a short. Now, we just take our camera and put it here. We arrange this cable under the fly controller and we put the fly controller inside. Okay, so after a few rerouting of the cables, I managed to arrange everything and everything looks to be alright. Obviously, this is the time where you need to, I don't know, be sure you routed everything okay. No wire is pinched, no device pads or anything is connected to the carbon so that you might have a short somewhere else. But usually this is the way I install it. Next thing I usually do is take the plastic nuts. Be sure the FC is properly seated. You don't have any pressures from the wires under it. And that's about it. Nothing else really to be done with Voltara and Ultra. You just solder, you use the cable to connect FC and ESC, and that's about it. Yes, if you have a digital air unit VTX, you might power it from the pads as well, but yeah, I don't know. Everybody likes to build their way, so this is how I build it, especially the analog ones. As you can see, I have plenty enough space here for the top plate, and there is plenty enough space on the top for a strap to pass under the top plate. It's a tight fit, but it's a tight fit with gummies or without gummies. So the next step in our setup would be to power up this setup right now and see how it goes. If you want to be on the safer side, power only the ESC before installing everything else. This is what I would do in a fresh build, but in this case I had already prepared the Ultra and the rest of them. I am not recommending using any sort of electronic saver or spark protection or short stopper, or I don't know what the names are. I would recommend for everybody that does anything FPV related to have a power supply, maximum of 3-4 amps with current limiting functions, and that's the best way to test a fresh build. I'm going to power up my power supply, and we have set it on 25.2 volts, which is the maximum of a 6S LiPo, limited to 3 amps, and let's power it. So we had all the correct bits. Next portion would be setting up everything on the flight controller side, check the rotation and see how everything goes. Okay guys, so I connected the KISS Ultra flight controller to the PC, and to make it even more understandable for everybody, I reset the flight controller to default, and right at the first connection it asks me to use the recommended settings, and I will accept this. You have the type, the motor output mapping. Because Voltara is 100% compatible with KISS Ultra, you could just go here and select which orientation you installed, like 90 degrees to the right, upside down, and so on. Right now we have installed as default, but you could also use the wizard to detect which motor is which. Okay guys, so if you want to check the rotation of each motor and change it accordingly to what's needed on your setup, you have two options. Do it manually like I do, which means rotating each motor and seeing which of the four rotates differently. For example, we have motor 1, which is left front, and it needs to rotate to the right. This one to the left, this one to the right, and this one to the left. I just rotate all. I notice which one is rotating bad, and I go to ESC Flasher and change the rotation from there. I will show you the both ways. If I go to OSD tab, I enter OSD menu, hardware tools, motor test, and you can select each motor. On the keyboard, you can use keyboard 1 to input 10% throttle, and you can see motor 1 which direction it will spin to. So we have, as you noticed, it rotates to the left. So that means motor 1 needs to be reversed. Motor 2 to the right. So motor 2 needs to be reversed as well. Motor 3 should rotate normally, meaning to the right. Yep, and it does. And motor 4 to the left. And it does. Right now I only need to reverse motor 1 and motor 2. So now we can go to ESC Flasher, and in the ESC Flasher we can see that we have 4 ESCs detected. This is the last firmware version 1.41, and we just need to change the 1 and 2 motors. If we go back to the OSD tools motor test and try to rotate motor 1, we can see it rotates to the right now, and motor 2 should rotate to the left, as you can see. Another way to set up rotation of the motors would be to use the wizard. We need to power the ESC up. We need to have the remote connected, and we can check here that we have indeed signal from the remote. We go here, we press wizard. We are welcomed with a message telling us that all 4 motors will be reset to normal rotation, which means default for the ESC itself. And when we press next, we will hear the ESC reset itself as a sign that it got reset. Now it selected automatically the output number 1, and we just raise the throttle a bit. And as you can see, it goes to the left. We are telling the wizard which of the motors just spun, which is this one. So it's on the left. We have selected left on the wizard. Now we click next. We have motor 2. Motor 2, it's currently spinning to the right, so to the right. We click next. We have motor 3, raise the throttle. Motor 3 is rotating to the right. We click next, raise the throttle. Motor 4 is rotating to the left. We click next, and it gives us all the information needed. Now we click save, and the ESC should reset itself with the new corresponding rotations. Now that we have the rotation correctly set up, and if we want to visually see all 4 motors at the same time, we can just select them all raising the throttle just a tiny bit, and this one rotates to right, this one to left, this one to right, this one to left. So we are done setting it up. Right now, the only thing needed is to close the frame, put some props on, and go fly. And that's about it. This is how easy it is to set up your quad. Obviously, this is my quad. I will need to put a zip tie here for the cable to be a little bit safer. I need to close it up, and I will come back in the following days with a flight video for the maiden of the quad. I hope you guys enjoy this. I hope it helped you in building, or if not in building, at least in seeing the product being installed in a quad, and how easy or not easy it is to build with it. Thank you very much, guys, and till next time, bye.